Welcome to Blizzard Fire. We hope this video helps fire up your solution.
You start by confirming Proteus has the virtual terminal component and your MCU model ready. Load the compiled firmware file into the microcontroller. Next, wire TX/RX from the MCU to the virtual terminal RX/TX pins and set the terminal properties for baud, parity, and stop bits to match your firmware. Once done, set the microcontroller clock and power rails correctly so the chip runs. Make sure the virtual terminal is placed on the schematic and not encapsulated inside a hidden subcircuit. Now configure the virtual terminal properties. Select the serial interface, enter the exact baud rate, parity, and data bits. Choose whether to link to a real COM port or leave it virtual. Then check the microcontroller's UART pin direction and any required pull-ups so signals drive correctly. Start simulation and watch the terminal window. If nothing appears, pause and verify pin labels match the MCU's TX/RX functions. Use Proteus debug probes to inspect TX line activity to confirm data is To finish, run the simulation and interact with the virtual terminal. Type to send data if the firmware supports input. Once you see expected output, stop and save the working schematic configuration. If it fails, a common fix is swapping TX and RX or correcting baud and voltage level mismatches. Make sure the MCU is actually executing code by toggling an LED or using a breakpoint. One key troubleshooting tip: attach Proteus oscilloscope to the TX pin to confirm physical signal activity before assuming a software fault.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.